Good evening, everyone, and welcome back to the class. It's your favorite math class with teacher Uche. Topic for today is fractions. Now, fractions are just part of a whole. Part of a whole. In mathematics, they are just part of a whole number. That is a fraction. So, fraction is in everyday life. Its application is in everyday life. We want to see the basics of fractions, and for today's class our concentration will be on proper fractions. Proper fractions are those fractions where the numerator is smaller than the denominator. That is a proper fraction. So that is what we are concentrating on for today's class. And let's see, a fraction is usually in two parts. A fraction is usually in two parts. We have, let's take 3 over 6 as our fraction. This one up here is called the numerator. We have numerator and denominator. So you have the numerator, and the digit we have below becomes the denominator. The denominator. So for all fractions, there is usually numerator and denominator. Now, we want to see how we can order these fractions. What do you mean by that? We want to know how we can easily decipher or decide which one is bigger than the other. There is a chart here that shows a lot of fractions. The first one we have here is not a fraction, it is one whole. As you can see, there is no division. But all these cardboards are equal lengths. They are of equal lengths, but we have divided them into different compartments on equal sizes. That is what we have done. So here, we have divided this cardboard paper into two. So 1 over 2 simply means share this one whole into two parts and take 1. That is 1 over 2. 1 out of 2. So whatever you have, the denominator is the number, represents the number of people sharing that item that you have in the numerator. So when we have 1 over 3, it means get one orange, share it into 3 equal parts. Now, with this, we can do something. Whatever you have here has been cut out in pieces here. We want to demonstrate something. Now, this is 1 over 2. 1 over 2. Let's bring 1 over 3. We have tried to cut out all these things. So this is 1 over 3. It is now clear to us, it's very clear to us, that 1 over 2 is bigger than 1 over 3. You can see the difference here. Now let's add 1 over 4. This is 1 over 4. And you can see that 1 over 4 is smaller than 1 over 3. Then we'll look at 1 over 5. This is 1 over 5. You can still see, still reducing, 1 over 5. Then we take 1 over 6. This is 1 over 6. Keeps going down. We have 1 over 7, 1 over 8. I have 1 over 8 here. It keeps going down. I have 1 over 10. 1 over 10 is 1/10. So share it into 10 equal parts and take 1. That is 1 over 10. You can see 1 over 10. Then we have 1 over 12. I have 1 over 12. You can see 1 over 12 here. I also have 1 over 15. 1 over 15 is here. There is also 1 over 16. 1 over 16. I have 1 over 20 as well. 1 over 20 is here. And the last fraction, the one I'm sure you're not seeing it on the screen, the one in yellow here is 1 over 24. 1 over 24. So this is what we have. And you can see the beauty of what we have created. This thing simply explains one thing. That for unit fractions, these are all unit fractions. And unit fractions are those fractions where the numerator are 1 in each case. Every unit fraction has a numerator of 1. So for unit fractions, the bigger the denominator, the smaller the value. The bigger the denominator, the smaller the value. You can see the one here. this denominator here is 24, 1 out of 24, is way too small than 1 over 2, 1 out of 2. So we now understand that for unit fractions. But there are other fractions. We have fractions that are not like fractions, they are not unit fractions. So how do we now know which one is bigger and how to handle them? Now, let's look at the fraction 1 over 3 and 1 and 3 over 8. Let's compare these two fractions, 1 over 3 and 3 over 8. Now, to know which one is bigger, we'll convert them to like fractions. And what are like fractions? Like fractions are those fractions that have the same denominators. So let's see how we convert these two to have the same denominators. The denominator here is 3, while the denominator here is 8. So we'll be working with multiples of 3 and multiples of 8. Now, what are the multiples of 3? Multiples of 3 simply means start with 3 and count in threes. So we have 3, that's the first multiple of 3. 6, 9, 12, 15, 18, 21, 24, and so on and so forth. We'll also take multiples of 8, which are 8, 16, 24, 32, 40, 48, and so on and so forth. Now, as if you observe these numbers we have here, the only thing they have in common, or rather the first number they have in common, is 24. If we keep going, you will get other common factors. But for now, we have only 24. And it is now 24 that is the lowest common multiple of 3 and 8. Hence, the LCM of 3 and 8 is 24. So what are we now going to do? For 1 over 3, it will now be 1 times, we'll be multiplying. Now, this 24 is the 8th multiple of 3. 1, 2, 3, 4, 5, 6, 7, 8. So we'll multiply by 8 for both numerator and denominator. And when we do this, we'll have 8 over 24 after this multiplication. Then let's look at 3 over 8. 3 over 8. We'll also multiply, but let's see the number we're multiplying by. Now, 24 is the third multiple of 8. 1, 2, 3. So we'll be multiplying by 3 in both cases. So we have 9 over 24. Now they have become like fractions. And like fractions, like we observed earlier, 8 out of 24 is smaller than 9 out of 24. When you share an orange into 24 parts, give somebody 9 out of it and give the other person 8 out of it, I think you have actually favored the person you gave 9. It's clear you have actually favored the person you gave 9 over the person you gave 8. So with this, we can now tell that 3 over 8 is bigger than 1 over 3. But we can still demonstrate it with the strips we have. However, under exam condition, you won't have access to these. But let's see what we can have here. We have 1 over 3, and the next thing we are looking at is 3 over 8. Then the ones we cut in 8, that's the 1/8 of each. So we are going to bring 3 of it, so that 3 of it will give us 3 over 8. Now this is our 3 over 8. We want to compare it with 1 over 3 and see if by comparison it is also bigger by comparison. Now look at what we have. Yeah, so obviously 1 over 8 is really bigger than 1 over 3 by inspection. Okay, so we want to take also 3 over 5 and maybe 2 over 10. Or let's say 2 over 5 and 3 over 10. Let's take 2 over 5 and 3 over 10. Now, the denominators we have here are 5 and 10. So we'll be working with multiples of 5 and multiples of 10 to get their LCM. Yes, you can use the normal division, but we prefer the multiples here. So we have multiples of 5 are 5, 10, 15, 20, 25, 30. Now, multiples of 10, 10, 20, 30, 40, 50. Now let's compare and know. By observation, you can see there is 30 here and there is 30 here. So 30 is a possible multiple of 5 and 10, but it is not the lowest, and we will always work with the lowest. We have 10 here and we have 10 here. So we are circling these people. Now, 10 is the second multiple of 5. So for 2 over 5, we have 2 times 2 over 5 times 2. Then 10 is the first multiple of 10. So for 3 over 10, we have 3 times 1 over 10 times 1. And 2 times 2 will give us 4. 5 times 2 is 10. Then we have 3 over 10. So obviously, 4 over 10 is bigger than 3 over 10. And we can still demonstrate it. 4 out of 10 is bigger. We don't even need to demonstrate this one. It's crystal clear. Now, okay, let's look at 2 over 5 and 3 over 10. We can bring it to the board. 2 over 5 and 3 over 10. So we're bringing the strips of 1 over 5. So we bring 2 of them. This is now 2 over 5. We want to get 3 over 10 and compare. See what is happening there. Remember, we have concluded that 2 over 5 is bigger than 3 over 10. But we just want to see what we'll get by this inspection and observation. Now, you can see that actually 2 over 5 is bigger than 3 over 10. So that is it about ordering of fractions, and we can still use this to do our addition and subtraction of fractions. So let us, here we'll be subtracting 1 over 3 from 1 over 2. So we say 1 over 2 minus 1 over 3. Now, we have all accepted that 1 over 2 is bigger than 1 over 3. So when we subtract, we want to know what we would have left. So 1 over 2, once again, the multiples of 2 are 2, 4, 6, 8, 10, 12, and so on. While multiples of 3 are 3, 6, 9, 12, 15, and so on and so forth. So the multiples that are common is just 6. 6 is what is common to both 2 and 3. So this our 1 over 2. 6 is the third multiple of 2. So we'll be doing 1 times 3 over 2 times 3. And for 1 over 3, 6 is the second multiple of 3. So it is 1 times 2 over 3 times 2. That will reduce them, or will bring them to to like fractions. So we have 3 over 6 minus 2 over 6. And all we simply need to do is subtract 2 from 3, since they are now like fractions. So we subtract the numerators. 3 minus 2 is 1. So we are saying it is 1 over 6. In other words, we are saying that when we remove 1 over 3 from 1 over 2, what we are going to have left is 1 over 6. And let's see, this is 1 over 2 and 1 over 3. Let's bring 1 over 6 and see how well it fits into the remaining space. And good enough, it fits well. Good enough, it fits well. So we are now saying that obviously 1 over 2 minus 1 over 3 is actually 1 over 6. This will help us understand fractions better, and as we progress, we'll get it more enjoyable. Thank you. Please like and share.